Okay, 3.1 is the last section that will be included on the next test. It's quadratic functions and models. So first let's talk about a polynomial. A polynomial function of degree n is anything of the form an x to the n plus a n minus 1. These are really just terms like, it's, for example, like 2x cubed plus 3x squared, so on and so forth, all the way down. The only rule is that the first coefficient can't be 0, because then it's not a polynomial of degree n, it would become a polynomial of degree the next one down, whatever the largest exponent you see is. The degree is determined by the largest power, as we just said. Something like f of x equals 2 when there's no powers of x is a constant function. F of x equals x plus 2 is linear. X squared plus x plus 2 quadratic, cubic, quartic, and so on. After about cubic, they usually just refer to them as like fourth degree, but they have names. But if you want to call them a fourth degree polynomial, that's fine. A quadratic function, or a quadratic function is quadratic if it's of the form ax squared plus bx plus c for a, b, and c elements of the complex. We're really only going to deal with the real coefficients, so you don't have to worry about any complex numbers being coefficients, even though you know what they are at this point. The simplest parent function for quadratics is f of x equals x squared, which you guys have all seen before. It is the parabola. Looks something like this. And it's got some features. The domain is negative infinity to infinity. The range is 0 to infinity. All parabolas have either a maximum or a minimum. Here you see it goes up forever, so it has a minimum. But if you have a parabola that's facing downward, because if there's a negative in front, then it will have a maximum. So this one is a minimum. It's really a minimum. The best way to write this is a minimum of 0, the height, y, at x equals 0, which is the x value of the vertex. So the minimum or maximum always occurs at the vertex. It's decreasing, so if we watch what it's doing from left to right, it's going down, decreasing from negative infinity to 0 until it hits the vertex, and there it's increasing. We know the vertex is 0, 0, and there's an axis of symmetry at x equals 0 down the center. What that means is that anything that's happening on one side of the parabola is happening on the other side, which is useful for graphing. There's even more information on the next page. The best form for graphing for a parabola is vertex form, which is this f of x equals a times x minus h squared plus k for a, h, and k element of complex. Again, we're only going to deal on the reals. H and k is our vertex, which is why it's useful for graphing. And what does a tell us? If a is positive, so the number multiplied in front is positive, it's the same a as the other equation has, and it opens up and has a minimum. But if a is negative, then it's a downward facing parabola and it has a max. We know from the last, or from 2.7, that if a is greater than 1, or the absolute value of it, it's a stretch, versus if it's a fraction, it's a shrink. H and k are a vertex. It moves the parent function right or left for h. Remember, it's opposite sign. K moves it up or down in the same sign as direction. So h and k are a vertex, which is why it's helpful for graphing. The maximum and minimum is, again, of k at h, of our y value at our x value, and it's symmetric about the line x equals h. So that's really easy for, vertex form is really easy for starting a vertex and plugging in points around it to get the shape of a graph. Now for standard form, ax squared plus bx plus c, the vertex is at the point negative b over 2a and 4ac minus b squared over 4a for the y value. Now, pause. You only really need to know that the vertex value, the x value, is negative b over 2a. This y value is the actual y value, but you can always get the y value of the vertex by plugging in the x value of the vertex, because remember, they're a coordinate pair. So if you find your x value and plug it in, it will get you the same y value without having to memorize that formula. Now there's an interesting part of quadratics called the discriminant, which we talked about a little bit in chapter 1. And that's the b squared minus 4ac, which is similar to what you see up here. b squared minus 4ac greater than 0. The graph crosses the x-axis in two places. What that means is you have real roots, because remember in the quadratic formula, this is what's under the root in the quadratic formula. And that means if you have a positive number, you have real roots. If it's 0, you have the same root twice, because our plus or minus will be adding or subtracting 0, which means you'll get the same number twice. So that means it touches the x-axis. You can either open up or down. Now, if you have imaginary roots where b squared minus 4ac is less than 0, the graph will not cross the x-axis at all. So it either starts above the x-axis and opens up, or starts below the x-axis and opens down. So let's at first just figure out what these features are going to do to our problem. Suppose you have ax squared plus bx plus c. A is positive, b squared minus 4ac is negative. Describe the characteristics of a graph and sketch an example. Okay, so if a is positive, that means it opens upward, which means it will have a minimum, like the original x squared. If b squared minus 4ac is less than 0, this is where we have imaginary roots, which means we have no real roots. Now, since it's opening upward, it must start above the axis. So what does that look like? It could be on the left or the right, but we know it doesn't touch the axis, and it's got to be opening upward. So here we don't have any real roots. There's a minimum down here at the vertex. It's opening upward, and it starts above the axis. So that's all the things we need. And like I said, it could be on the left, it could be around the middle. It's just a sketch of an example of what it could be. Suppose f of x equals ax squared plus bx plus c. For a is less than 0 and b squared minus 4ac equals 0, describe the characteristics. A less than 0 means we have opening downward. And if it opens downward, it has a max. The vertex is a maximum. B squared minus 4ac equals 0 means we have one real double root. And it touches but does not cross the axis. So what does that look like? Well, we know it's opening downward, and we know the vertex is on the axis, so say right here, it opens downward. There's a double root there. And we will continue this in the next video.